Hi, I'm Kian, and today I'm going to teach you how to find the formula for a series and find if it converges or diverges. So we have this series 1/2 plus 4 over 9 plus 9 over 28 and plus 16 over 65 and so on. So first I'm going to find the formula for the series. So I write series from n equals 1 to infinity, and I can write this value because it's a rational function, because I know it's a numerator and denominator. So if you take a look at numerator, we see it's a perfect square. So I can write it as n squared. And also in the denominator of the numbers, we see that 2 is 1 cubed plus 1, 9 is 2 cubed plus 1, 28 is 3 cubed plus 1, and 65 is 4 cubed plus 1. So I can write it as n cubed plus 1. So now I want to show you how to use the direct comparison test. So first, I want to first find a limit that we know the value when it converges or diverges. So if you divide this, we're not working with 1, but with n squared and n cubed, we get 1 over n. So for direct comparison test, we should choose a limit that is similar to this and then compare those to find if this also converges or diverges. So for part we know is that the sum from n equals 1 to infinity of 1 over n, we can use p series and because it's a power of 1, this is equal to 1, this is divergent, and also because this is a harmonic series, we can also conclude this is divergent. So now we can set up an inequality, and the inequality is the sum from n equals 1 to infinity of n squared over n cubed plus 1 is greater than or equal to, because it diverges, from the sum of n equals 1 to infinity of 1 over n. Now because it's an inequality and both have the same sum, we can cancel out the sums, and what we're left with is n squared over n cubed plus 1 is greater than or equal to 1 over n. And now we can use the cross multiplication if we multiply this by this. So what we get is n cubed is greater than or equal to n cubed plus 1, and if we subtract both sides, we get 0 is greater than or equal to 1. And this is wrong. So direct comparison test is wrong in this case. So now our next step is to use the limit comparison test. So we want to use the limit comparison test. So we have one known limit and then another limit that we want to, a series that we want to solve for if it diverges or converges. So what we should do is that we should take the limit as n approaches infinity of the original function, which is n squared over n cubed plus 1, all over the series or the sequence we know that is divergent or convergent, which is 1 over n. And if you multiply both sides by n, this cancels. We get the limit as n approaches infinity of this is n cubed over n cubed plus 1. This is a very nice limit because we're working with the highest power. N cubed divided by n cubed, this is equal to 1. So we can say, because the limit as n approaches infinity of this sequence approaches to 1, so we can conclude that the series from n equals 1 to infinity, if I call this, for example, an, diverges by limit comparison test. And also if you want, you can put also diverges because we're comparing with 1 over n. So we can say the limit from n equals 1 to infinity of an also diverges by limit comparison test. Thanks for watching. Please subscribe and let me know what you do next.